So today we are going to discuss as a part of Kubernetes deep dive. So the first thing, like, we have to understand the Kubernetes architecture and their components, and then we will see how to install Kubernetes on your on-premises with using a different container runtime interfaces. So we will discuss later, like, what is container runtime interface, how many ways that we can integrate your container runtime interfaces into your Kubernetes cluster. So first and foremost thing is nothing but when you want to deploy some Kubernetes setup, uh, we are completely using this on premises, in the sense we are not using any cloud service like AKS, GKS, or EKS services right now in this particular session to form your Kubernetes cluster. So entirely we are doing from scratch, which means that we are taking some bare metal servers, but in this example you will be using virtual machines instead of bare metals. Okay, that's the only difference. Apart from that, you are doing something like on premises. We are not using any cloud service providers. So to form this, okay, what are the components? So first and foremost thing is nothing but what are the components that need to be installed in order to form your Kubernetes cluster. So the components you will be dividing into two parts. One is master node components, which is also called as control plane. So technically from here on you need to call this particular node as control plane node. Okay, and these nodes, which we generally used to call as worker nodes, now you can call it as compute nodes, which means that technically now everybody is following this naming conventions. Okay, though this diagram is a bit old, but here you can assume that this is a control plane node. Okay, and you can see it is compute plane nodes. Okay, so what are the components? So if you look closely, we have three different components, and we have etcd as well in this particular component to store the entire cluster related information. So let me talk one by one, which component will come first and which component will accept the request and all. Let us try to understand one by one. So if you look closely to this, when you execute some command, or when you are using some dashboard, or when you are running some curl like API calls, what are the medium it is you are using to communicate to your Kubernetes cluster, the first component who will receive the information is nothing but API server. Okay, why API server? Because you need to be verified who you are and what you can do. Okay, so that need to be verified, right? So that particular thing will be done by your API server, which is also called as authentication and authorization. So once the authentication and authorization is done, as everybody knows, I guess, authentication is nothing but verifying the user. Okay, in this Kubernetes cluster, we can verify user based authentication, username password based authentication, key based authentication, means nothing but a certificate based authentication, and then token based authentication. Okay, so this you can understand this particular concept in, we have a separate session for that, authentication and authorization, which is like RBAC as well. We will be talking more in depth about it. Okay, so right now when someone is trying to execute a command, it will just verify who you are, okay, and what you can do. Okay, so these things will be verified. Once that particular thing is done, it also does like schema validation, in the sense what are the parameters you are passing, it will verify whether you have passed all the important parameters or not. Okay, which are needed, which need to be passed, those parameters you have passed or not. Let's say if you are trying to create some pod, or if you are trying to create some namespace, or if you are trying to create some particular object on Kubernetes cluster, it will verify the schema for every API. Whatever the object you are trying to create, every object will have a specific API. Okay, with specific API, in the sense that particular API will have certain protocols that need to be followed in order to create that. Okay, if I want to create a pod will have certain parameters, right? You need to pass this name, container section, container name, image, okay, ports, okay, and then volumes. So there are so many other parameters, so it will validate that. So once the validation schema validation is done, the next component who will come into picture is nothing but etcd. The next component, what it does exactly, it is a key value pair storage. It is a key value pair storage, which is like, we have other components like console, we have redis. Okay, these are the best examples for your key value pair store. Okay, what they do, they store the metadata information, which is nothing but a variable and a value. So that's how it will be stored. So the entire cluster related information will be stored in the etcd. So this is a main component for us for your cluster to be up and running. If this component is down, okay, your entire, let's say it is crashed or something went wrong, you cannot access your cluster or you cannot see the data related to your cluster. Entire cluster is crashed. Okay, so that's the reason always it is better to take a backup of this particular etcd component. Okay, how to take a backup and all, we have a separate session for that as well. So there we can discuss in depth about this particular component, and you will get one particular question. Either it could be a backup or it could be a restore for your CKA and CKAD exam. Okay, so you have to when we could talk about that, I will be talking like what could be the question, how you need to answer that, how to solve that particular question and all, we will discuss there as well. So once the API server has verified, it will talk to the etcd and it will see whether this component already exists or not. If it is not exist, it will tell to the etcd that okay, please try to store the information, I am going to create this. So this etcd will store the information. Okay, now I have told you one point that the entire Kubernetes cluster related information is stored in etcd. So who is giving this information? Is etcd going and collecting this information, or is there any other component that is giving this information? Yes, exactly. So etcd is not doing this. Okay, etcd responsibility is to serve the data and like store the data, okay, in the key value pair format. Now who is taking the responsibility of giving this particular cluster related information? That responsibility is taken care by your control manager. So control manager will observe your cluster state, each and every node, each and every components running on each and every node. If something goes wrong, it will intimate you. It will store the information in the etcd as well. So that's the reason when you execute some commands, you will see the information of each and every object. That is only possible because your etcd is having that information. And who is giving this information? Your control manager. So control manager is giving this information to your etcd to store that. What this control manager will do, it will keep on with certain interval, it will keep on observe your every node, every component and every application which is running inside. Okay, so that is taken care by your control manager. So if you are using cloud, it is called as cloud control manager. If you are using on premises with kubeadm or some other tool you are trying to spin up, this is called as kube control manager. Okay, in this it will control so many things like replicas, namespaces, service accounts, node components, everything will be controlled here. Okay, let's say you created some pod in the replica. If one of the pod is down, then control manager will observe that and automatically it will tell you to the API server that okay, I am the like the user is expected to have 3 pods, the desired pods, but now I can see only 2. So automatically it will intimate to the API will verify this and then it will create that particular component. Okay, so that is how this control manager will do. Okay, so that is a responsibility of control manager. If you are using cloud premises like cloud Kubernetes cluster, it is called as cloud control manager. Okay, the naming convention is different but the responsibility is the same. Okay, now there is one more component called scheduler. What it does then, every component is having some responsibility. What is the responsibility of this particular scheduler? Scheduler responsibility is to decide on which node you should launch this particular object. Let's say I want to launch some application using pod. Then who will decide? Who will take a decision? You have so many compute nodes, right? In that compute nodes, which one should be available to launch this particular pod? So scheduler will decide based on algorithm it has, it will decide which node is suitable to launch this particular application on that particular node. It will decide, it will take a decision and that decision will be given to the API server. API server will store the information and then this information will be passed to your respective worker node. Let's say it is assigned to this particular node. Then the API server, once the acknowledgement and everything is done, it will give the information to the worker node. Okay, you need to remember one more thing. Once the API server job is done of passing this information to the cube to this particular node, is it talking directly to your backend container runtime interface? Container runtime interface in the sense the actual component who will create the pods, sorry, containers. Okay, the actual component who will create a containers for us. We can use Docker, we can use containerd, we can use CRI, we can use any other tool which is supported by Kubernetes. Okay, by default till 1.21 release, we are using Docker as a default one generally. Maybe 1.22 you might heard about news that Docker is getting deprecated for Kubernetes. Yes, it is true. From 1.22, Docker is no longer supported in Kubernetes as a container runtime interface. So you need to use containerd, which is the best suitable for production servers as well. Why? Because I'm telling that because Docker is even using containerd to create pods. Then why I need to pass information to the Docker and then to the kubelet, right? Sorry, the containerd, right? Why I need to have a latency in passing this information? So that's the reason Kubernetes has decided that why can't we pass the information to the containerd component to create the containers. So that's the reason they have deprecated. It doesn't mean that you should not learn at all, but for this particular Kubernetes it's not feasible solution for us to use Docker as a container runtime interface. So we will be both the installations and configuration using Docker. We will see as a container runtime interface, and we will see using containerd as well. Okay, both the videos will be available. So now once the information has been passed to your worker node, the responsibility of your master node is done. Okay, the control plane node is done. Once it is reached to the compute node, who will take this information first? The API server to whom it will talk? It will talk to the kubelet service. Kubelet service is a component who will receive the information, and that's how the information will be passed to your backend container runtime interface, and that runtime interface will create a containers for us. Okay, you already know, or we will be discussing about that. The pod is nothing but a containers. What pod does? Logically it will give you some functionality, that's it. The actual application is running inside the container, even in Kubernetes. Okay, so that's how it is. Then what about Kube-proxy? Kubelet responsibility is to create containers. Okay, create containers, and this is not this component, but actually it will talk to the respective container runtime interface. Now what is the responsibility of Kube-proxy? When you look into your networking and all, if you want to access your application from outside, or any other component wants to talk to your application inside and all, Kube-proxy, network proxy will come into picture. Okay, where it will add IP table rules and it will remove the IP table rules when it is not needed, and all everything will do, and it will take the responsibility of network packets to get bypassed. Okay, so you will talk we will talk more about this. Right now Kube-proxy responsibility is for network proxying to your components, backend components, what you are using for application. Okay, so these are the whole bunch of components. But most of the things, when you have learned or when you read the documents, nobody talks that kubelet and kube-proxy will be running on the master node as well. To be frank, I'll show you practically as well. The actual thing is kubelet and kube-proxy also will run on the your Docker. As usual, you already know that Docker need to be installed on all the nodes. First, how many nodes you are trying to take into your cluster? On all the nodes you need to install your container runtime interface, for example Docker containerd or something. Okay, once it is done, if you see not only these components, okay, this makes difference actually. Why these diagrams are designed like this is, this makes the difference from the control plane node and compute plane node. But actually your kubelet and kube-proxy also will run on this particular node. Why? Because few pods will be running on this node as well. If you are using kubedm tool or any other tool, or manually if you are trying to bootstrap, all these components, right, control manager, scheduler, etcd, will be running as a pod. That pods will be running on the master node actually, to be frank. Okay, so those components will be running. Okay, so don't assume that kubelet is running only on the worker node. No. Okay, kubelet and kube-proxy will be running on this node as well. Why? Because there will be some pods will be running or will be scheduled on this node as well. Let's say if you are using some monitoring tool, you need to collect the data from all the nodes, right? You cannot skip this control node. You need to collect the logs, and you need to collect other information from this node as well. So then you cannot ignore this one, right? So that's the reason I'm telling you that kubelet and kube-proxy also will run on this node. Okay, we will see practically that as well. And the next thing what you have to understand is, there are other two components which are really responsible for your DNS configuration and networking. For DNS, those are called as add-ons. Okay, So this we will discuss in depth, okay, when we talk about the differences between Docker and container D. Then I will explain more about this. Okay, right now keep it aside. Okay, you can just look at this particular diagrams. If you scroll down, you can see here add-on for Kubernetes DNS and networking. These are add-ons like integrated to have networking and DNS. DNS in the sense, if you want to communicate from one component to another component, one application to another application, we can, instead of relying on IP address, we can communicate through DNS names actually. So that is only internal within the cluster. From outside the cluster, you cannot do that. Okay, even from the node also, you cannot use that particular DNS names. Why? Because those DNS resolution will happen only from inside the container, from one container to another container. But if you try to do from the cluster, if you are in the cluster, let's say you logged into this particular node, control plane node, and if you try to run ns lookup or dig command to that particular DNS name assigned to the pod or a service is actual DNS. Okay, when you try to do an ns lookup, it doesn't resolve. Why? Because it is within the containers itself. Okay, from the container, inside the container you can run the ns lookup, which is really useful for me, right? See, that is only internal DNS. If my container is able to resolve to that application, another application with that DNS name, I'm happy. So no need to do it from the node level, right? So that is the one. Okay, and the next component is container network interface, which is called as CNI. Every pod or every service which you create later will have some IP address assigned. That IP address, assigning that IP address and recreating that IP address, DHCP, everything will be taken care by your container network interface. Here in this example, we will be using Calico. Why Calico? Because it provides you network policies. Calico is the best for production as well. And then it has BGP peering support, multiple CIDRs which we can enable. So there are a lot of other things which we can implement using Calico. Flannel earlier we used to use for testing purpose, but it is not production graded, and this is also deprecated actually. Then we have WaveNet. AWS has its own networking, Azure has its own networking, Google has its own networking. Okay, if you want to use Calico, we can use it. Okay, it's not that we cannot integrate, we can. Okay, but by default, if you are using AKS, GKS and all, they provide their own networking. Okay, core DNS is something where for Kubernetes internal and cluster DNS service. Okay, so this is the high level view of this particular Calico components. We have a separate session on this. What is this component, what it does, what is the responsibility when you try to create a pod, how a request will come to the Calico component, who will take the responsibility of assigning the IP address and all, we can discuss here. Now it is high level, just I explained you all the components so that everybody will not get deviated or doesn't think that it is too complex. Okay, so let's now go ahead and let's see how to install your Kubernetes cluster on GCP. I'm using GCP. Why? Because on my local nodes, a local Oracle VirtualBox, right, which I'm using right now, I just want to show you one example related to using containerd as a runtime interface. In this Google, I'm using some free account. Okay, we have a separate video. I will give you in the this particular session description. You can watch in that particular description. I will give you a link to watch about this particular how to create a GCP account for free. Okay, for 3 months actually it will be free. They will give you some credits. If you want to see that in my account, if you go to billing, if you scroll down a bit, yeah, here you can see I was given with 21,000 and I was left with 16,000 right now in the current situation, but it is expiring in 3 days. Still I have 16,000, so I can use like anything for this 3 days actually. Okay, so this is what I just want to explain. So we will go to the compute engine in the compute section. Then here I will be creating two nodes right now. One is control plane node and one is one compute node. Okay, two nodes. So to create that, you can see an option here, create instance. Simple. Instead of creating on my local virtual machines, I'm creating on GCP instances. That's it. It is also called as, for example, in our point of view, it is called as on premises. Let's think like that. Okay. So I will give some name called control plane node. This we'll call it as control plane so that I can understand. I'm creating on this region and this zone. I'm not too much worried about this. And how much you need to allocate. for this particular nodes on your Kubernetes cluster. The minimum is 2 vCPUs and 4 GB actually for Kubernetes also, for Kubernetes nodes. Here also it is by default selected with 2 vCPUs and 4 GB. Okay, but I will be increasing it to I will be increasing it to 2 vCPUs and 8 GB RAM since I have some resource. Okay, here I want to use I want to use Ubuntu 20.04 LTS server edition. So change the operating system type and the version 20.04 LTS. Okay, and the disk size 40 GB, 30 GB is enough for me right now. Okay, 30 GB is enough, more than enough actually. Okay, because I have a quota limitation on whole, how many VMs you create in your account, it should not cross, the disk size should not cross more than 250 GB. That is my quota limit. So that's the reason I gave pretty less, which is fine for me for this particular experiment. Now default access, this is fine. Firewall, I just want to allow all the traffic, but in real time we allow only the port numbers which are needed. But right now, since it is my account, I'm using this particular traffic to allow HTTP and HTTPS. Okay, create. So this will create one node, and meanwhile let us try to create one compute as well. So let's go to this compute. I will name it as compute node 1. Why I'm telling like node 1 in the sense, tomorrow I will just integrate node 2, second node, to an existing cluster. So then you will have some naming convention, proper naming convention, right? So that's the reason I gave compute node 1. Okay, so this is what I'm giving. Then let us change this to 2 vCPUs and 8 GB RAM, and here I want to change it to Ubuntu, and then same, whatever I did for the first VM, it's the same. Here also 30 GB, it's enough for now. Select, this is fine, and then create. Done. So both the VMs will be ready, and you can see here this VM is ready right now. Okay, you can see now both the VMs are ready right now, instances are ready right now. Technically in cloud it is called as instance, but nothing but VM. Okay, so these two instances are ready. So let me log into the first instance and let me do some particular stuff, because it's a new VM. Okay, new virtual machine which is created right now. So on Ubuntu, what you need to do before proceeding further? Okay, let me log into this as well. Okay, the font has been increased so that everybody can see this particular commands what I'm typing right now. So I hope this is logged in. Yeah, let me enlarge this. You can go to your root user by using sudo space -i. Okay, now the first command on Ubuntu operating system which you have to do is nothing but update your apt database. Okay, why is this needed? Because this is a new VM. If you want to download some packages and all, without running this update command you cannot download, because it doesn't know what is the repositories you have. Okay, so this is the thing which you have to do on Ubuntu. After this, let's say this, when this ISO was created, this image, technically in what do we call, in cloud it is called as image, right? So this image, when was created, it has some particular versions of packages. Now I want to upgrade the packages to the latest version. So to do that, dist upgrade. Okay, if there are versions which older version, then it will try to upgrade them. If it is upgrading your kernel as well, then you have to restart this particular virtual machine. But I see there is no kernel which is getting upgraded, so no need to worry. Okay, same thing I will do on this node as well, my compute. Okay, so till I say something, command should be executed on both the nodes. Okay, so apt update, and after this dist upgrade. So done. Okay, what is the next to form your Kubernetes cluster? So the next thing is nothing but you have to install your container runtime interface, right? So that is what I need to do. What happened? It's still going on. Yeah, so it is going on. Let's wait. So it is done here on this control pane. The task has been done. You can see my kernel version right now. Sorry, my bad. You can see this kernel version. And remember one more point, you have to disable the swap memory. Okay, how to disable we will see in the next video when we are using our local virtual machines. Okay, when you are using GCP account instances, by default swap memory is disabled. You can see there swap memory is disabled by default, so no need to worry from my end. If you are enabling swap memory, you cannot form your Kubernetes cluster. The command bootstrap command itself will fail. Okay, so keep eye on this particular point, which is important. Okay, swap memory should be disabled. Okay, on both the nodes it is disabled, no need to execute on both the nodes. Now what we need to do after this, we have to install container runtime interface, right? So to install that, I'll be opening the browser, then go to your Docker official page, install Ubuntu. Search like this, you will get your official page. Use this the first link, scroll down a bit, it is supported to install on Ubuntu 20.04 LTS as well. So I'm fine. Go ahead. First I need to so I need to install update command is already done, right? So now I need to install some few packages which are important to run to proceed further. Actually, to proceed further and execute some other commands, these packages are important, so that's the reason we are trying to install it. Okay, so on the second node I need to do the same thing. You can say on the compute node as well. Now go back to the documentation. Okay, now execute this command as well. Okay, this is nothing but it is downloading the GPC key, official GPC key for your Docker repository, because your node has to communicate to that repository. If you have this particular key, GPC key, then only it can authenticate and then download the packages. Okay, for that this GPC key is important, though it is open source. Okay, I'll come back to my control node. It is done successfully on both the nodes. Next, I'm using architecture AMD 64 or x86 64. How will you come to know that? You can execute this command. Okay, so based on my architecture of the node, this is what I need to execute. If you are using any other architecture, then we have to use that. Okay, in my case, I'm executing this command. What this command does, it is creating your local repository to communicate to the Docker repository to download the packages from that repository which are important for your Docker. Okay, so that is, so this will create a file under /etc apt source.list.d. You can see there, this is the file. So this file has the information related to how to communicate to your repository, Docker repository. Okay, so same command I need to execute on the compute as well. Done. Okay, remember on Ubuntu operating system, whenever you add a new repository, you have to run an update command. Okay, like this, when you added a repository like this, you have to execute. Okay, there is no other choice. If not, it cannot download from there. Update, and on the compute also just run update command as well. So on both the nodes, once a new repository is created, whenever, keep a note, whenever you create a new repository, while like this using echo or any other thing, if you are using a direct command called apt-key add something like that, no need, automatically that command will run update as well in the background. Okay, since we have added like this, we have to execute. Nothing wrong, right? See, even if you execute once again, it doesn't harm you. Okay, now we need to install the packages. So to install the packages for Kubernetes, it is recommended not to install the latest version. It is better to install 19.03 version. Okay, so how will you verify that? Let me tell you. These are a few basics of your Linux operating system. Cache, policy, this is especially for Ubuntu. And let's say I will give one package name. You are installing three packages, right? Docker-ce, Docker-ce-cli, and containerd.io. Let me give something like Docker-ce. If you see, if you don't specify anything, version number and all, it will by default, if you specify this package name like this, it will install this particular latest version. Okay, you can see in the candidate section. Right now it is not installed, so that's the reason it is none. Candidate in the sense which version will get installed by default. But I don't want that, I want to install 19.03. Okay, so I want to install this. So what you need to do, apt install -y docker -ce equal to this number. So same thing you have to do for other packages except this. Containerd is not this package. Okay. So docker -ce-cli. Try to execute this one as well. Equal to, and then containerd containerd.io. Same command I'll just copy paste so that on the second node I can execute the same command. Okay. Both the nodes you have to install. How many nodes you are using in the cluster? On all the nodes you have to install the same version of your container runtime interface. Don't mess everything. Okay. So be careful, be patient enough while executing this kind of commands on when you're trying to install a specific version. If you are installing default version and all, no need to worry too much. You can just execute the command, copy paste, that's it. But when you are installing a specific version, you have to be careful. So this is done almost. So I will go to the compute and then execute this. So it's almost done. Let's verify. So how will you verify your Docker version? Docker hyphen version. It's installed. If you want, you can see the service is running on the backend or not. Docker hyphen c. Sorry, my bad. You can see the service is running fine. I can execute Docker CL commands as well. Okay, so perfect. My container runtime interface called Docker got installed successfully on the compute as well now. Okay, it is completed. So Docker hyphen version done. No need to execute the same commands. No need to too much. So done. Our first task was done successfully on all the nodes. How many nodes you are using on the cluster? On all the nodes you need to execute this. Next, what we have to do? Now I need to install the Kubernetes components, right? So kubeadm. So we have so many tools. The recommended and the best way to install your Kubernetes on premises is kubeadm tool. We are having kubespray, we have minikube, other tools as well. I'm not using those tools because not those are not that user friendly. Kubeadm is so simple to understand and to bootstrap your Kubernetes cluster as well. So use this particular documentation. I will give you in the description, in the video description as well. You can just go through these particular links, whatever I've used. Okay. So let's scroll down. You have so many things here. Let me remove this one actually. Let me go to the kubeadm, create a cluster. So you can see install kubeadm. Just click on that. Here, these are the specifications which we have already followed. Use 2 GB of minimum RAM, 2 vCPUs or more, full network connectivity, which means that I have internet connection as well as both the machines can communicate with each other. Okay, unique host name, MAC address, everything I have followed. Next, last point you can see here. Okay, this is really important for us. Disable swap memory, just have spoke to you, right? This is what it is. Okay, you have to disable. So these are the things which you have to follow before you are actually forming your Kubernetes cluster. Okay, so this thing I have followed. Then the next one is nothing but we have to update our IP tables and the bridge traffic, right? So to do that, we have to enable some module and we have to enable some particular bridge IP table firewalls as well. Okay, so to do that, you can just copy paste these commands. This is one command, this is another command, and this is the third command. Okay, so let's copy paste at a time and we can execute. Control pen. Okay, so let's execute this. Okay, done. Right? So this is done. And on the compute node, you have to do. See, whenever I say something, then only you have to do on a specific node. But until I say that, you need to execute on both the nodes. So firewall, we enabled all the traffic, right? So no need to worry about firewall. But if you are using beyond the firewall, then for the control plane, you have to enable these port numbers, and for the compute node, we have to enable these port numbers for your Kubernetes cluster to be up and running without any issue. Okay, there should not be any network blockage. Then we have to enable these port numbers in the firewall. After that, we installed the runtime, which we already done. You can see here Docker or containerd or CRI. Okay, so we have already installed Docker, right? So then go back to form your Kubernetes cluster. We are using kubeadm tool. For that kubeadm tool, we need additional two packages, nothing but kubelet and kubectl. kubectl is actual package who you will use the CLI tool to communicate to your Kubernetes cluster, right? That CLI tool is nothing but kubectl. Okay, if you want to create some a pod, you want to fetch some information from the cluster, create some particular object in the Kubernetes cluster, everything you will do from kubectl command. Okay, whether it's a declarative or imperative. Declarative in the sense you are writing YAML file and you are creating your object, or else from the CLI itself we can create with the options, we can create our object. Both the ways it is done through kubectl command. Okay, kubelet is a component which will be running on all the nodes, which I have already told you in the architecture. Like kubelet should be running as a daemon, it's not as a pod. This kubelet will be running as a daemon, like a service how your Docker is running, right? In the same way, your kubelet service will be running as a daemon on all the nodes. Why is that running as a daemon? Because it has to control your pods creation and the containers creations. Okay, that's how. And the kubeadm is actual tool which we will be forming to form your Kubernetes cluster. This is the tool who will be which will be used to form your Kubernetes cluster. First, we have to bootstrap the control plane node, and then we have to use the kubeadm command to join other nodes to the cluster. Okay, the first node which we will try to spin up is nothing but control plane node. Okay, you have to decide which node is your control plane, but I've already decided by assigning the host name as control plane. So I decided that this node should be a control plane and this node should be a compute plane. Okay, so fine for me, I have already decided that, but these packages need to be installed on both the nodes. Okay, so let's follow. Update, it's already ran, so we have to install these packages once again to proceed further. I think these packages are already installed, so fine, done. These are installed. Next is nothing but you have to download your GPC key for this as well. Since I'm using root, no need to give sudo. If you give sudo also nothing will happen, but it's not necessary. Okay, now I need to create a repository in my local system to communicate to the Kubernetes repository and download the packages. Okay, so this is the repository where your local mission will use in order to download the packages of your Kubernetes. See there, kubernetes.list, and for Docker it is having a docker.list. So Docker related packages will get downloaded here, Kubernetes packages will get downloaded from there. Okay, now this is done on both the nodes, so I'm good to go. What is the next command you need to run? Always whenever you add a new repository, update. Okay, on the control plane also just update. Done successfully. Okay, now we are installing the actual packages. Those are nothing but this. So here we are not installing the latest version. I see some particular discrepancies, so that's the reason we are installing latest version of Kubernetes below of it. Okay, latest is 1.22. I think it is still under development. I see some particular issues, so that's the reason we are installing 1.21. Okay, in the 2.1, what is the latest version? Patch version. See, here you have 1.21 dot, and then you will see one more version. So one is nothing but main version dot minor version dot patch version. So we will be using the latest patch version in 1.21. Okay, so let's see that before installing. So how to see that? You already know, apt-cache policy. Look at any one of the package that is enough. Okay, let's say kubeadm. You can see we have so many, right? Let's scroll up. Sorry, oh god. So now if you scroll up a bit, you will see the latest version. Huh? This is like, okay, yeah. Let me give something like less. You can see here, if you don't specify anything, this will get installed 1.22.1. Okay, but I want to install 1.21.4. You can see this. Okay, this is the patch version, latest patch version. The major means like the latest patch version of 1.21. So I'm good to go. Okay, I can use this one, right? So let's use that one. Okay, so quit. Now to install, apt install -y. So to proceed further, kubeadm equal to this, and then kubelet equal to this, and kubectl. All are using the same version. Done, right? So let me copy paste this particular command on another node as well. Okay, I already copy pasted. Let me do on, oh, why is this happened on this compute as well? The browser is like expanded like anything on the compute node as well. Okay, this is controller, it's already done. So packages got installed successfully. You can see like this, grep hyphen capital E kubelet and then kube adm. Done. You can see there, install successfully, done, right? On both the nodes it is done, so no need to verify on compute node as well. Okay, now from here you need to do on a specific node. Till here whatever we have done on both the nodes. Okay, now we need to do on a specific node. So you decided that this is my control plane node, and you decided that that is my control compute plane node. Now this node should be bootstrapped first in the cluster. Any first node which is getting spinned up is called as bootstrapping. Okay, which you're trying to make that particular node to to initialize the cluster, that is called as bootstrapping. Okay, first we have to bootstrap this particular node. Before that, let me verify the internal IP. See, you cannot see a public IP. Don't assume that you can see this public IP which is assigned to the node. These are floating IPs. You cannot see inside the container. All the containers will, sorry, my bad. All the instances will communicate with each other using this private IP address. Okay, internal IP. External IP is just not constant. Tomorrow when you reboot your instances, automatically this IP address will get changed. It is not a fixed IP. To use fixed IP, you need to use elastic IP. Okay, so we are not bothered about that right now because we are spinning up on internal IP. Okay, so go to this particular control plane node. This is the first node which we have to spin up, and the node IP address is 110.128.0.28, right? So remember this. So we need to use the first command. Kubeadm is a tool which we have to use, and init. What are the other options we need to pass? That is important. Okay, so give help. You'll get so many options actually. In this, two options are important. One is pod network CIDR, and one more is API server advertise address. You can see in the documentation as well. I'll scroll down a bit. You can see in the next page, use kubeadm to create a cluster. Okay, so scroll down a bit. Okay, here you can see API server advertise address. Okay, you can give your interface name, which address. See, why we are giving this is nothing but we are binding our API server to listen on that IP address. Okay, that's the reason. Okay, I have these many. Let's say you have so many interfaces in production. If you want to bind your API server to listen on a specific IP address, then we have to do like this. Okay, got the point what I'm saying? So kubeadm init API server advertise address 10 dot, or I can give interface name as well, 10.128.0.28, and the next parameter which we have to give is nothing but pod CIDR. So that you can get it from here, pod network CIDR. So catch this point. Documentation is not that straightforward to understand for newcomers, but since I have some experience on this, I can tell you like which points need to be followed. Here, what is pod network CIDR? This is the CIDR which will be used in order to allocate the IP address to your pods. Whenever the pod is created, it should get an IP address, right? From this CIDR only, it will assign the IP address. Since we are using Calico, okay, since we are using Calico, I will open the documentation. Okay, I'll tell you how to verify this. Calico install Kubernetes. Okay, search like this. You can click on the next second link. You will get something like quick start. You can see here quick start. Okay, now you can scroll down. These are the functionalities which you get when you are using Calico by default. Here you can see it is telling you that by default it will use this. If you are trying to deploy your Calico YAML files, once actual task is done, init is done, these are the files which you have to execute. Once you execute this particular file, it will use this particular CIDR automatically for Kubernetes, for your pods. So you have to specify which. When you want to customize, let's say this particular series IP address you are already using for your nodes, you cannot use the same series for your pods, which will get conflict. Then you have to customize. To customize that, first you need to download this YAML file, you have to modify this CIDR, and then you need to apply this YAML files. So when you're bootstrapping it, you have to be careful while passing the CIDR. Okay, in my case it is 10 series, so I'm okay to give this particular CIDR, right? So this is the CIDR. How many IP addresses we can use with this CIDR? 65,535. So 65,535 pods can use this IP address. Will you install those many pods? Technically speaking, no. But this is sufficient for me. Okay, so let's go ahead. There is a simple problem, which is nothing but it is telling you that please enable this particular parameter as well. So how to do that? Simple. Copy this, okay, and just try to do echo 1. You just need to add one number integer to that particular file. Okay, on both the nodes you have to do. Okay, maybe this point is missing in the documentation since we are doing it in our GCP instances, right? So maybe that's a reason. Okay, we are done on the compute. Let's do on the compute. Yeah, done, right? So now let's go ahead. Now you can see it is going on. So what is needed for your Kubernetes cluster control plane to get bootstrap? All the things will be done one by one. Okay, it is downloading the images first. After that, it is generating the certificates. After that, it is creating the config files. And after that, it is creating your pods related to your Kubernetes, API server, control manager, scheduler, and then etc. All these pods are getting created one by one. Okay. Once that is done successfully, then it will show you successfully done. Now you can see your Kubernetes control plane has been initialized successfully. So which means that successfully one task is done. Your node has been bootstrapped successfully, but it is not done 100%, right? So to go further, we have to start using this cluster, you need to run the following commands as a regular user. So just create this directory. That is what it is trying to tell you, and then it is asking you to copy your main configuration file to this particular directory with this particular file name. Why? Because if you want to execute kubectl command will search for this particular file under the home directory. Okay, so that's the reason we are copying this particular file to this file in the home directory. Okay, if you don't want to do that, you can just export. But the problem is whenever you try to log in, a new terminal will open, right? Always you have to execute this command. Okay, next it is asking you to deploy your container runtime interface, sorry, container network interface. So since we are using Calico, I will deploy that. And the last one is you can copy paste this particular command. This is the actual command which we are using to join the worker node to the cluster. Okay, so copy paste somewhere as your wish and save it this after that particular networking task is done. Okay, once that is done, once this particular task is done, we have to run this particular command on the worker node. How many worker nodes you have? On all the worker nodes you have to execute this. You can see here. Then you can join in any number of worker nodes by running the following on each as root. Okay, so go back. What you have to do now, as I told you, you need to execute this command to deploy your Calico Tiggeria operator, and then you need to deploy your Calico components. So copy, paste on the control plane, don't do on the compute plane. Okay, copy this command. This is also done successfully. Okay, after this what you have to execute? Your kubeadium on the worker node, right? Copy, I already copied it in my notepad, and then let me paste on the compute plane. This you can see it is getting joined. Once it is done successfully, it will tell you whether it is done or not. You can see here this node has joined to the cluster, certificate signing request, everything is done. Run kubectl get nodes on the control plane to see this node is joined or not. So go back to your control plane, execute kubectl get nodes. If this node is not ready, it doesn't mean that you are not successful in deploying it. No, there are certain pods which should be created in the background. Okay, they are in the creation status. Let's see. kubectl get pods -n all namespaces. So this will tell you, see, meanwhile when we are executing, they are done actually. Okay, so these pods are running state, and these are in ready state. Sometimes you might see 0/1 0/1 in the sense there is some issue in this container. It doesn't mean that if it is running, it doesn't mean that your container is up and running, your pod is up and running. Your containers also should be in ready state to accept the request. Okay, so keep eye on this, both the columns. Okay, now all are running. I expect that all the nodes should be in ready now. Okay, so this will confirm that your nodes are ready and your Kubernetes setup is up and running with Docker as container runtime interface. Okay, with this we are done with Kubernetes setup on GCP instances with Docker as a container runtime interface. In the next session, in the next video, we will see how to form your Kubernetes cluster on your local system with virtual machines and the container D as your container runtime interface. Okay, we will see that right after this. Okay, thank you.